All right, welcome back to a new TouchDesigner tutorial. And in this one, we're going to look at a technique that I call time grids, which enables us to display any animation in TouchDesigner as a flexible grid. And we can change the size of the grid, we can change how fast it's being recorded and things like that. So this is the network. So we're going to be working sort of inside of this custom component, and the grid is going to be rendered in a render network. And then we've got 5 different examples here. One being sort of the main one where you can use any network that you like. So any of your toxes, any of your projects, you can kind of just copy and paste in here and then play back to see them as a grid. And then I'm going to show you a few different examples of how you can work with really precise animations from start to end. How we're working here is with the texture 3D, as you might have guessed, but not exactly in the way that usually you work with it. Just going to quickly show you the examples. So the first one is just a regular noise. Then the other one I just showed you, we're going to work with a little ramp here. We're going to look at how to just make something grow over time. And then the last example is actually showing frames from a video. So you can use any video and display its frames as a grid like this. All right, so without further ado, let's get started and make this from scratch. Cool, so as always, I'm gonna delete everything, and that means deleting this component. And I'm gonna recreate that. And so we're just adding a base component here, and I'm gonna call it time grids. Then we want to make this a custom component with custom parameters. So I'm gonna customize this component. And the first thing that we wanna add is an integer called input res. And we want to make the default here 512, the minimum also 512, and the maximum like 1280. Then I'm going to add a pulse, and I'm going to call it start. I'm going to give it a section, so we can see there's a line between these now. And then I want to add 2 more ins, one being length. And here the default is supposed to be 10, minimum maybe like 2, and maximum maybe like 20. These are sort of arbitrary. You can change these always, just feel free to adjust as you like. And another integer that is called grid size. Another section. So for grid size, the default is going to be 4, minimum 2, maximum. Let's work with 8 here. One last thing I want to do here is add a keyboard in and just use that on the start. So whenever I hit 1 on my keyboard, we're hitting this button start here. Okay, so let's dive into here, and I'm gonna create the grid render setup first. So to do that, I'm adding a rectangle, and then to that, I'm adding a transform, and then the usual things that we need for render setups. So geo, camera, render, and we want to have a constant material. And we want to change our camera to orthographic. I'm going to change the ortho width to like 1.3. On my render, I'm going to change the resolution to 1280 by 1280. So I think with the grid, it works best if we're working with a square resolution. I'm going to add a null, call that BG. And on my camera, I'm also going to just turn on a black background. What we want to do now is work with instancing. So I'm going to add a grid, and I'm going to right click on my time grids here, parameters, and then use my grid size for the rows and columns. So then we want to add another transform as well as another null and call this one pause for position, as we always do. And then on my geo, I'm going to go to instancing, turn that on, use position, and now we got a white render. Perfect. On my rectangle, I'm going to go down with the uniform scale to 0.2, and now we got a nice grid here. So we might want to go down with the transform scale, maybe to like 0.7, so the grid is a bit more dense. Now let's actually have a look at the textures. So I'm going to start with a noise for this example, as very often. Just going to change a few parameters here so we can see the changes over time a bit better. So I'm going to add the classic ABS time dot seconds times 0.2 expression, and then we can already see this is working nicely. Maybe something like that. So we want to make slices in time of this. And to do that, we use the texture 3D. So by default, this is what it looks like. By default, the cache size is 32. So we can already change the cache size to our desired size. So we already defined a grid size of 4. So that just means 4 by 4, actually, as you can see here. So it's either the horizontal or vertical. You could technically define different rows and columns if you like, but I'm just going to work with one value. So I'm just going to put that in here. Actually, before we do that, I'm going to go back here and go to common. And on my parent shortcut, I'm going to call this time grids. And this is really useful because anywhere in here now we can call this and we don't need to do any like parent to or whatever expressions. So actually I'm going to reconnect these. So they're nicely, like now you can see what it says here is parent.timegrids.par.grid size. And you can use this anywhere in a network. So that means even if we have another base component in here and we go inside that, the connection still works as well. So I'm just gonna drag that in here and just gonna multiply by itself. So basically like X by Y. And now we got nicely like 16 different cached kind of versions of our input here. But there's several issues. So first, we will need to change this to 2D texture array if you want to work in the way that we do. And so one thing is that it kind of records every frame one after the other. So we could change the step size here, for example, to 10. So now it only records every 10 frame. We can even go way higher to like 50. And then that already looks much closer to what I would like it to look in the end. The issue here now is that it just keeps going, right? It doesn't stop. It just like keeps going and going. You technically also have to prefill, but as you can see, that's also not really what we're going for. You could work with the prefill and then animate this with me.time. And then you do prefill. Yeah, it basically, and then you can turn off active and then prefill. And it sort of works like that. But then again, it only works with like me.time and it's not very flexible. There's a much nicer way to actually do this, and that is by replacing single. Let's say I want to replace the second frame here. I could just define replace index 1 and then hit pulse. So whenever I hit pulse now, it's going to grab the current frame and replace that specific index. So I could also do it with the last one. So 15, hit pulse, and now you can see that last one is being replaced. So now you might already sense that we can create a nice chop network to do this for us. So to do that, I'm going to be working with a timer chop because we also have something that is called length here. And I'm going to use the start as the start here. And I'm going to use my length as the length here. So now if I hit 1 on my keyboard, because we connected that in the beginning, right? I'm actually starting this timer. So I'm going to go to outputs and turn these off because I'm only interested in the fraction in this example. So now what we can do is we can actually use a math and then change the range to the amount of slices that we want to have. So that again is the grid size times itself. And then actually subtract 1. So put that in brackets and do -1. Cool. So now we got that figured out. But the issue is now that you can see it, it's a float number. And actually what we want to have is an integer. So what we can do here on the math is just integer floor. And now we can nicely see that this is being updated perfectly. So now we can just do like add a null, call that null index, and use this value as a replace index. And another thing that we might want to do now, that we actually have to do, is from here I'm going to add a logic, because what we want to do is every time the value changes here, we want to hit this pulse button, or kind of make TouchDesigner hit it for us. So I'm going to add the logic, change that to on when value changed. So you can already see like every time this number changes, this is being triggered. But actually I noticed it's not being triggered enough. Sounds interesting, but yeah. So actually we want to use a trigger here, get rid of all the stupid default values. And we actually want to change the min sustain length here to maybe something like 4 frames. So it's a really nice clean signal that stays on long enough, because when we keep working, at some point you might notice, if you don't do this, that it doesn't really like pick up every change, or it doesn't really like trigger the pulse here reliably. So this is a good way to go around that. So I'm going to call this null pulse and use that on the pulse. So now if I hit 1 on my keyboard, you can see it nicely goes through all of them, replaces one after the other, and then stops, right? It doesn't restart as I showed you with the when it's turned on active. So this way we're already recording nicely over time. So we could now change this to length maybe 3. And then the difference between each frame is obviously quite different. So it's also nice now that we're kind of nicely in control, because we can define kind of how the grid looks in the end, because like this way, like each frame is kind of similar to the next. And then if we do maybe like length 24 seconds, the change in each frame is more drastically different, because there's just more time that passed between each recording. Cool. Now what we can do is add a null. It's called a null text, and just use that on the constant. So for now, what that does is just taking the first frame, so this one, and just kind of copies that over every tile. So what we want to do is actually create another index here for the instancing. And we can do that nicely using a ramp top. And I'm going to change the pixel format to 32-bit float, the Y to 1. And then again, we can use the same expression that we used before. Just use the grid size times itself. Then all we got to do here is add a math, very similarly to what we did here, actually. So we can just use the same expression on the math, go to range, put that here, right? And then what we can do as well, or what we have to do as well on the integers, changes to round. Then add a null, call that index. And what we can do now is right click, like turn the display on, right click display pixel value. So now we can see it nicely goes up from 0 to 15. And on our geo, we can now go to instance 2, use this as the text record OP, and then use R as W. So now you can see it nicely, maybe let's do this quicker, maybe like 7 seconds. We can nicely see that it's being updated one after the other. Now, the weird thing is that it starts from the bottom left. So all we need to do is go to our transform and rotate this on the Y and Z axis by 180 degrees. And then now it starts at the top left and goes to the bottom right, as you might, it's more intuitive that way. Okay, so I'm gonna take the timer away here and just select all of these, right click and collapse selected. And then we can call this slicing. And we might want to give it a color, because it's like the main thing here. And the cool thing about what we did before with the parent shortcut here is that on, for example, here with the parent.timegrids expression thing, we now put that into the base, but it still works just as well as before, because it doesn't matter in which level it is with the parent shortcut. So it's really quite a good practice to do when you're working with components. Now what we can look at is actually creating different examples. So right now what's happening is that by the way, if something is not working well, which I haven't told you yet, you shouldn't work in real time. So always turn real time off when you're working with this technique. So just when you're working with this, just make sure that's always turned off. So currently this noise is just kind of running, and then we're kind of recording that. It's fine, you can work that way, but I also like to be more in control here of how this animation is working and kind of be independent of my main project here. So I'm gonna just right click while having selected that anywhere, collapse selected, and I'm gonna call this just like project, because you can literally work with any of your projects here. I'm gonna give this a violet color, And what I'm going to do here is right click and then add component time. Because what we want to do is we want to make this independent. So you don't have to do this, but I kind of like working this way. So now it's an independent timeline. Well, actually, it's not yet. It's just got its own timeline. But to be independent of the main timeline, we gotta click on this eye or go in here, time, run independently, turn on. Now we just got a noise in here. And for this example, I think that's totally fine, totally sufficient. Yeah, we can just kind of leave it that way. What I want to do here now is go into local time, turn play off. So just change it to 0. And now what I want to do is use my timer fraction here. It's going to add a null. And then we want to go through frame by frame based on the timer. So this is especially useful when you're working with something like feedback loops. It's not technically super necessary, but it's just nice to be in control of the animation. So what we can do here, OP, and then talk to project, local, and then time, dot frame plus equal 1. So if I hit 1 again on my keyboard, it just like kind of goes through the animation here. That's basically it. This is just a noise, but you can just copy and paste any of your projects in here and work with them if you like. And again, if you don't like to work on this independent thing, you can also just work with the base without the local time thing here. Before we go on, let's add a switch from here. What the hell? Looks wrong. It's a weird bug there. In the newest version, Greg. Yeah, and let's add a fit because we want to make sure that our input here is always the same resolution and always kind of the square resolution. So let's do fit outside, and the resolution here we can change that to our input res. Cool. And then one thing that I also like to do here is add a little border around every tile. So a good way to do that is before we do the slicing, it's just to add a little border. So I'm going to change the rectangle size. So I added a rectangle, change the size to 1. Let's get rid of the fill alpha, border color white, change it to pixels and just do 2 pixels. So now we just got a nice little border around every tile. You can increase its size if you like. I don't. Or change the color on a border color, whatever. So the next example, what we're doing here is we can just, just work with any animation. We're kind of just starting off randomly. So when we're hitting 1, it's just kind of starting any time. But this doesn't work so well when we actually want to work with a precise start and end point. So I'm going to show you how to do that now. So I'm going to add a null, right click anywhere, collapse selected. And I'm going to call this noise sphere and give this a color. Let's move in here. So what I want to do here is build another little render setup. So I'm going to work with a sphere, a noise, and we're going to need a transform. Let's turn off this stupid animation of the subs. Never good to animate subs. And from my transform, I'm going to add the geo and work just as we did before, setting up a little render network. So we want to have a camera. In this case, I actually want to have a line material. And I'm going to render this, of course. So again, we might want to use our input res here. And on my camera, I'm going to change the background to black. And then I'm going to add an out. So we can grab it from here and put it into the switch. So for now, it's just not animated. So it's just going to be one thing. So again, we could actually turn on the animation of the noise here. And now we would see that already looks cool as well. So you can totally work with that. But what I want to do is I want to have like a smaller sphere with no noise in the beginning, then get bigger like over time with more noise, and then get smaller and no noise again. So to do that, I'm going to create a little animation channel here. I'm also going to change the period down to like 0.3. And again, we don't want to have animation. So to do that kind of from 0 to 1 back to 0, that's kind of a sine wave. So what we got to do is use a pattern and just change the phase to 0.25 and change the range from range to -1 and 1. And now we got a nice value going from 0 to 1 and then back to 0. So now what we can do is use a lookup from here and then use this as a second input. So now what you can see, if I press 1 again, it goes up and then it goes down in the course of the 7 seconds that I've defined here currently. So I'm going to add a null. Let's just call this null amp. And let's just copy and paste that and add a math before the second one. So for the second one, I want to change the scale here. So I already know I want to have a scale between 0.2 and 1. So for the amplitude here, I can literally just take the 0 to 1 range. So I'm not adding a math. And here I'm just using that for the uniform scale. So now let's have a look if I press 1. So we start with a very small sphere with no noise, and then we get bigger, more noise, and then we're going back again. So that's nice. We might want to change the grid size now to something like 6. And you can see actually that there's a problem here. And yeah, one thing that I forgot actually is that you have to change the pulse here as well. So you have to actually reset the whole thing every time as well. Okay, so that works nicely. I'm going to change the scale of my tiles here manually for now. We're going to look at that later on. So sometimes you can see it doesn't actually pick up everything. So for that, you might want to increase your length. And again, it doesn't pick up everything perfectly. And that might be because our nulls here are set to cook type automatic. And for some reason that doesn't work in this example. So here I would change them to always. So now you can see it really nicely picks up everything. So actually we might want to add a transform before the end here and just add a black background so we don't have that weird alpha thing happening. Right? Looks a bit better. Cool. So that's it for the second example. Let's keep on going with the third one. So I'll just copy and paste this one, this base, and I'm just gonna call this ramp. And just gonna get rid of all of this. We just wanna have a null here and ramp. On my ramp, I'm gonna add some colors. So I just wanna have a really intense red and then a sort of violet color and then like an intense orange color, something like that. And I want to change it to circular. And what I want to do now is use this on the face and just change the period to 2. So now if I press 1, you can see it just kind of moves through the ramp once. So again, we can use an out. And then we can use that here, change input to 2. And then we get this nice ramp animation. So I might want to make the uniform scale a bit smaller so we get like a padding between them, margin, I mean. And that looks pretty funky. You can maybe change the orange a bit. Yeah, it's a bit nicer. Right, that's it for the third example. Let's move on. And I'm gonna change this to noise circle. And this is quite similar to what we just did. So in this example, I'm just gonna add a noise, change my period here to 3, harmonics to 5, amplitude to 2, and exponent to 0.5. And then what I want to do is animate this based on this. So that would be one idea. And I'm going to show you another idea in a minute. I'm going to add a circle and do operation multiply. And then I'm going to add, just copy this and add a math in between. And I want to change the circle size from 0.05 to 0.4. Just put that on here. So now you can see it nicely grows over time. I'm gonna add some colors. So I'm gonna add a lookup and a ramp. And I'm just gonna work with a sort of orangey, brownishy color here, and then like an intense red. Looks kind of nice. And then again, we just need an out top so we can send the data out to the higher level. So I'm gonna put that into the switch. And now we can see that nicely grows over time. And I think it looks really nice, sort of like a moon-ish. thing. So now it's going to be the same noise every time. So there's two ways to change that. So the first one would be to just do the animation as we do usually. So maybe like ABS time dot seconds times 0.2. And now it's going to be a different noise all the time. That would be one idea, but if you kind of like one noise and you want to work with this setup and you want to be more in control, you can do like that, and then we can add a parameter chop and go 2 levels higher. So we're going to there and then the time grids, which is this. So we're grabbing these parameters. I'm going to select start, add a count and a null. And I'm going to call that null seed. And then we're going to use that on the seed parameter. So every time I press 1 now to restart it, it's going to have a different seed. There's always many ways to achieve a solution to a problem. So whatever floats your boat here. Okay, last but not least, we want to work with a video. So I'm just going to call that video and just get rid of all of this stuff. So obviously we want to work with a movie file in, and I'm just going to copy the path. So I got just a regular landscape video, not very interesting. So what we want to do here, by default, it's set to play mode sequential. We want to change that to specify index. And by default, that's set to me.time.frame. So it's gonna be linked to the timeline here. So you could kind of work with that, but we want to actually define the index ourselves. So we can kind of go through it manually like this, which is generally a really cool thing that we can do in Touch. To be able to go through the whole video, we need the information of like on how long the video actually is. So I'm going to add an info chop and just drag that on here. We can select the true length, and then we can add a math and a null here. And I'm just going to call that null index. I'm being super consistent with adding null and not null before names here. Great. Anyways, what we got to do here is go to the range and use this and then subtract 1. And then technically what we can do is use this as the index here. But now you can see this actually shows a warning because it creates this feedback, not a feedback loop, but a loop. To go around that problem, there's a little hack. We can just copy and paste this movie file in, right click on the file, and just paste the reference here and use this second movie file in instead. So also we don't want to play this one. We also don't need to define any index here. So this way we're kind of going around that issue. So now as you can see, if I press 1, we're just going through that entire video in the speed of the length that I have defined here. So we're going to play that video back in 12 seconds. And now what I can do is add an out again. And if I go back here and put that in here and then go 1 index higher, you can see we can play back that entire video nicely. So obviously it doesn't pick up every frame. It only picks up every X frame depending on how long you play back, or mainly depending actually on the grid size, right? If you were to display the entire video, you would have to think about how many frames there are and then how many grids that you would need. So you could technically go up maybe to 8, and then you can already see, well, it picks up more frames, but there's also this issue that it doesn't pick up every frame. And that's generally a thing, like when you go up with the grid size, you want to also go up with the length. So maybe with a length of 20 now, it works nicely, because otherwise it's just too fast for it to kind of save the frames. So one thing that you might notice here is when we change the grid size is that these scales here aren't working very well. They're not dynamic, right? So you could change the grid size and change it manually. So that's totally a way to go about this. I've sort of found a solution for it, but it's definitely not perfect. So if you have a better solution, then please let me know. I'm going to show you that anyways. So we can add a parameter chop here and just select the grid size. Right now that's 4. So first off, what we can do is we can add a math and then add a null here. And I'm just going to call this null grid size. And then for the math, what we need to do is we need to add the minimum and maximum in the range. So if you have different ranges, then like a different min and max, then you also need to adapt that here. And then for the grid size now, I want to change that to like 0.6 and 1. So I'm gonna use that as a uniform scale on my transform. So you can already see kind of like when I change my grid size here, it also changes the grid size here. So our actual like SOP grid. And another thing that we can do, and that's a bit hacky, is adding a function, changing it to input one, whatever, this little roof exponent, power 2, I think. And then we can add minus 1.1. Just add a null here, call it maybe null tile size. And then we can use this on a uniform scale of our rectangle. So now if I change my grid size here, it's sort of and dynamically adapts to a certain degree. It's not perfect because it's not always exactly the same padding around the whole thing. Again, margin, I think, not padding. Padding is inside, right? Anyways, so it's not perfect, but it works sort of. I think it's still better than adjusting it manually, but you can totally do that. And again, if you have a better solution, please do let me know. And yeah, that's kind of it for this video. I really highly encourage you to not just take these examples as they are, but really mess around with your own project. So especially in this first one, you can just easily copy paste any of your projects and just kind of play them back as tiles, or display them as time sliced grids. But also for the other ones, I encourage you to get creative and to play around with also these kind of animation curves, right? You don't have to use this sine wave. It could be any other thing. You could even use the animation comp, even though that's a dark place to go. And obviously you can do post-processing, whatever, right? So feel free to really play around with this. If you want to support me on Patreon, there's a link in the description if you want to have some exclusive content. And thank you for everybody who is supporting me, and thank you for watching, and I'll see you in the next video.